Half past, it is time to get started. Welcome to this session of the DETNET working group at IETF 119. Lou Berger and myself, János Farkas, chair the working group. We are thankful to our secretary, Yves Schuler, for taking care of minutes. And we also thank our on-site delegates, facilitators, Don Fedik and Balázs Varga, standing in as Lou and myself are remote. Next slide, please, Don. This is the IETF Note 12, under which we have conduct our business. It is standardization activities. I would like to remind you that by participating, you actively accept that all the contributions, that is everything you say or write, become part of our permanent records. If you are not familiar with the noteware, please check at your own leisure. Next slide, please. And also the IETF conduct guidelines asking us and suggesting behaving professional to our colleagues. Please follow that and behave accordingly. Next slide. I guess everybody is familiar with the participation with these tools. Next slide. I just want to save time. Yes, please join note-taking. Lou provided the link to the chat window as well. And next slide, please. Yeah, before that, this is the second session of the DETNET working group at this IETF. We had our first session on Monday on wireless topics, and also started a little bit on a couple of contributions on enhanced data plane. For this session, the focus is on the enhanced data plane. After updates on requirements, taxonomy is a key aspect of our discussions. And our last interim this year was about taxonomy. Thanks to the contributors, we had a really good discussion on taxonomy. This slide and the following slide is actually our slides from David Beck. And a bit driving this discussion, what we expect. Ultimately, we expect from the taxonomy to characterize the number of queuing proposals on the table. And if you go to the next slide, please. So we would like to progress somehow on selecting which queuing mechanism, which proposal would be DETNET queuing. And for that, we need a better understanding. That's what taxonomy helps. And as we concluded at that interim I mentioned, the taxonomy draft on the table is a really good start, is a beginning of the discussion, and thanks to the contributors, authors, we are getting an update on that one. With this, I would not spend more time, but pass over to the next one, which is the updates on the scaling requirements draft. I think, Peng, you would be talking to it, so please.
So this button goes forward, it works. Thank you.
Good morning, everyone. Calling from China Mobile, and this is about the requirements for scaling DETNET. And the status, this document was updated from version 04 to version 05, according to the discussion around last meeting, which I mean that we received several comments before the meeting, but after the cutoff. So some of the differences or updates was presented in last meeting, and the changes are more about add some text to enhance the explanation of requirement. And I think it is stable and close to the last call according to the milestone of the WG. So the main updates are here. In section 3.7, we add the text related to consider end-to-end jitter bounds, achievable end-to-end latency bounds, and complexity in evaluation and selection of scalable DETNET queuing mechanisms. And this section was discussed a lot of time, and the final text was provided by David, and it was also presented in last meetings. And in section 3.8, we add some text about providing queuing solutions with multiple levels of DETNET capabilities as queuing mechanism development. It was showed in the figure at row below. So it's not separate requirements, but just some text to be added in the text. And for the section 10, we'll change the reference from normative to informative and correct some minor spelling errors. So here's an overview of technical requirements. It's mainly about section 3, and I think they are stable now. We may have some had some discussions. More of discussion happened in requirement 4, requirement 6, requirement 7, I think. So other requirements haven't got so much of the comments. So since most of the changes are presented in last meeting, we don't really talk so much details in this meeting. And the next step is that to say how to coordinate with a draft taxonomy and to see if there's any enhancement of the requirement draft. And we also hope more review before the last call. Thank you. Any comments?
Thank you. I see no comments. Let's move on to the taxonomy presentation from Gino.
Good morning, everyone. I'm Gino Jung. Data plane enhancement taxonomy. This is version 1. Actually, this draft was requested to be initiated by the chairs to better understand the current solutions of the DETNET working groups. So I'm at the presentation at the interim meeting on January this year. And during that interim meeting, we had some comments. And based on the comments, this version 1 has been produced. Okay, so let's go to see the overview of the draft. The purpose of the draft is to facilitate the understanding of the data plane solutions, which are currently suggested or can be suggested in the future. So the scope is to provide the criteria for classifying data plane solutions and to provide examples of each category. And the strengths and the limitations of the categories are presented as well. And according to the comments in the last meeting, in this version, the suitability of the solutions of the DETNET services to the solutions, that suitability aspect has been added. However, the candidate solutions currently being suggested is not described in detail intentionally. So that's out of scope. Here in this draft, we use the term solution, but it is not a single functional entity, but a combination of multiple data plane functional entities, such as regulators, queues, and schedulers. And those solutions can distribute it over a network. For example, a regulator at the network edge can be a part of the solution. Yeah, these the ones you have to understand for the draft. And before going into the main taxonomy, I'd like to introduce some of the solutions currently used in the DETNET working group, and some other examples mentioned in the draft. The current solution of DETNET can be of 4 types based on its origin. For example, many of the current solution is originated from CQF. They are SCQF, TCQF, and ECQF currently being processed in the IEEE can be a part of the solution being proposed in the DETNET working group. The second type is fair queuing variant. Fair queuing is a very specific solution that has been suggested from 30 years ago. We have one variant of fair queuing. It is called C-score. Another third type. The third type is time-aware shaper variant. We have one such solution called TQF. And finally, we have EDF-based solution. Interestingly, in DETNET working group, that solution is called EDF, but it is different from the original EDF. So you have to be aware of that fact. So these are the 5 types of currently proposed DETNET solutions. And in the draft, some other examples are included as well. They are ATS and deficit round robin. So these are all the solutions mentioned in the draft. And according to the comments made in the interim meeting in January, in the draft, we have also mentioned the DETNET service category as well. This categorization is based on the current working group document, this one, requirements for reliable wireless industrial services. In that document, a service is characterized by its latency requirements, burst size, and its periodicity, and the network scale. For example, the display information service defined in section 4.4 in that draft, we can categorize it. You can characterize this service as loose latency bound, and large burst, non-periodic, and small-scale service. So based on this characterization, we can categorize services like that. Now this is the main part of the draft. How can we categorize solutions? In this draft, there are 7 categorization or 7 taxonomies. You can see them, the taxonomy name on the left of the table. I won't go into detail all the taxonomy and the categorization because it will take some time. You can take a look at the draft. But however, I will just go briefly over it. The first taxonomy is about the performance characteristic. The name of the taxonomy is the per hop dominant factor for end-to-end latency bound. Every solution can be categorized into one of 3. Let's call it category 1. Category 1 is max packet length over service rate. Category 2 is sum of max packet length over link capacity. The third category is sum of maximum burst size over link capacity. So it may be very confusing, but in terms of the value of that category, the first and second categories are of similar level. They are similar. Because the service rate is something that allocated to a single flow, and the link capacity is over all the flows. So sum of the maximum packet length over link capacity is similar, the category 1 value. However, the category 3 value can be much larger. The second taxonomy is periodicity. One can be categorized as periodic or non-periodic. The third category is network synchronization. A solution can be phase synchronous, frequency synchronous, or asynchronous. how can you define asynchronous? How can you define synchronous? That is kind of tricky. And in the draft, we suggest the criteria called MTIE. What is MTIE? You can take a look at the draft because I don't have time to explain it. The first category is traffic granularity. How fine, how coarse a scheduler handles the traffic is the traffic granularity. It can be flow level, flow aggregate level, or class level. So as you can see, the more finer the flow level solutions are very, I can say, a flow protecting or flow isolating kind of property. However, the class level solutions are much simpler to implement. The next taxonomy is about the work conserving manner. A solution can transmit packet as soon as possible, whenever it is possible. Then it is work conserving. Non-work conserving solution does not send the packet even if it is available. So we can divide these two. And according to the target transmission time, whether there is target transmission time or not, we can define solution to be on time or in time. On time solution have certain target transmission time or target transmission interval. If a solution does not have such a target, it is in time. Finally, solutions can be defined by its service order of the packets from different flows. How can you decide the service order of packets from different flow? If it is rate-based, then it is categorized rate-based as well, and so on. There are 3 other categories. So these are the taxonomies of the draft is proposing. So this is the main part. From now on, I will try to give you some more information which is not described in the draft. So from now on, I will go faster. The 7 taxonomies you just saw seems parallel and independent, but actually what happened is they have some rough intercorrelation, rough dependency. For example, traffic granularity, whether it is flow level or class level, and the per hop dominant factor for end-to-end latency bound is somewhat related. How are they related? For example, flow level solutions have category 1 or category 2 end-to-end latency bound factor. So L here is the maximum packet length of the flow. Small r is the service rate of the flow. And the sigma means sum of the L over R. Large R is the link capacity. So there are 3 categories according to the dominant factor. These two taxonomy can be put into together like that. And as you can see, there are many solutions that are part of one of the categories. For example, C-score is flow level solution with this latency bound characteristic. CQF variations are class level and these performance characteristic. However, in the interim meeting last time we have a comment from Norman Finn, that CQF and its variance can be category of 2 when the burst is suppressed to a packet level at the network edge. This is what happens in the CQF. That is what I've heard. And if that is the case, burst size becomes exactly same as the maximum packet size, and these two cannot be distinguished. So the CQF and variance can be categorized into this category. But anyhow, the main principle of operation is not changed. Just the performance level becomes the same. So this categorization still holds. And Another grouping of those taxonomies, the second grouping of taxonomies are more complex. They are involved with 4 taxonomy types. Actually, this can be quite rough, and I'm not so sure. I cannot assure you that this is the right figure because there are so many other aspects that has to be considered as well. But according to the current solutions being proposed in DETNET and the additional examples I suggested, this is valid categorization. For example, work conserving, based on the work conserving or not, this can be divided into 2. And if one is work conserving, then it has to be in time. It cannot have any particular target transmission time. On the other hand, non-work conserving solution can be either in time or on time. And on-time solutions, which have target transmission interval, can be further categorized as non-periodic and periodic, and so on. The periodic solution can be divided into 3 different categories, but all the currently suggested solutions in DETNET is only frequency synchronized solutions, and they are all periodic, and they are all on time and non-work conserving at all, etc. So based on this taxonomy grouping, there are 4 different types of solutions currently being suggested. Finally, service order is quite independent from each other. And the current solutions are either rate-based or time-based. So this is not the whole picture of the taxonomy. Rather, it is a taxonomy for the current solutions only. Okay, so yeah, I think this figure very well categorized the current solutions in the networking group. So how this categorization fits to the current services being proposed in the networking group. This taxonomy, this categorization is for the DETNET service, right? And this other part is about the DETNET solutions. They can be mapped roughly like that. The same color pair matches well with each other. For example, if a service wants a tight latency bound, it can be better be one of these 2 categories, or flow level solution. If the service is strictly periodic, then the solution can be periodic, and so on. If the service has large burst size, then flow level solution may fit well. And if the service is for the large scale network, then rate-based or class level solution may fit well. This is just a rough match, not 100% correct. This is just a rough matching. So I try to summarize the strengths of each category with this box, with pointing box. Is it pointing box? Yeah, anyway. Yeah, from left to right, I will just simply explain what are these aspects. The rate-based solutions fit well to large-scale network. Why? Because the admission control is simple. Only the sum of the service rate of all the flows depends on the acceptance of the flow. That decided the acceptance of the flow. So it can handle larger number of dynamic flows where the flows join and leave very quickly. So rate-based solution have that strength. While time-based solution has simple end-to-end latency calculation. It's very straightforward and it is very intuitive. That's the strength of the time-based solution. The flow level solution. The flow level solution can minimize the effect of other flows burst or its existence. So it can be called as flow isolation property. The flow level solution protects or isolates a flow from each other very well. So if a burst size is very large for the services, then flow level solution fits well. The class level solution has a very obvious strength. It's simplicity. It is very simple. It does not need flow state maintenance. So it fits well to large scale network. It is very well known fact, I guess. You may not very well understand the work conserving scheme. So I'll take some time in presenting the work conserving scheduler's strengths. Its strength is the statistical multiplexing gain, which is the key strength of the internet, how it has survived, how it has succeeded. Well, it has much lower average rate, and it also has the maximum observed latency. So every solution can has its theoretical maximum bound, maximum latency bound. Regardless of that theoretical maximum bound, this work conserving solution can have much lower observable maximum latency. So it's a part of the strength. Another one is that because of its efficiency, the low priority traffic or the best effort traffic has much more room to be served. This is the work conserving scheduler's strength. On the other hand, work conserving scheduler has drawback of burst accumulation. The burst accumulation means the maximum burst size of the same flow, a single flow, increases over hops. That is called the burst accumulation. Because of the burst accumulation, work conserving scheduler may need more buffer space. So the non-work conserving schedulers have that strength, opposite strength. It has less buffer required, and it has less jitter, and so on. Yeah, and periodic solutions naturally fits the periodic services as well. Okay, so I think this concludes the talk. The final one I'd like to show you is that then how this taxonomy can divide or distinguishes the solutions currently being proposed based on the flow level or work conserving or periodic synchronization. The current solution being proposed can be categorized into this one, non-work conserving flow level solutions, and class level work conserving solutions. And TAS variants and CK variants, they are slightly different, but anyhow, they can be considered as periodic class level solutions. These are also rough visualization. Okay, thank you. Please take a look at the draft. And these are the references we have used as a taxonomy, the DETNET solution, enhancement solution. There are quite a few, you can take a look. And also Norman Finn's ECQF references also included. Thank you. Any question?
Yes. You've got Shafu.
Hi. This is Shofu Pan from ZTE. Jinu, I thank you for the presentation. Yes, it's very helpful. Can you turn to page 11? Yeah.
Can you specify? Yeah.
Yes. Thank you. For the rate-based category, I may have different opinions that the admission control of rate-based solution I think it may still rely on the burst resource. That is, they may need to manage the buffer resource on each node for all flows. I think I can give an example on the main list. Thank you.
Thank you for the question. If I understood correctly, your question is that even rate-based solutions need to consider the buffer space
Yes,
and the maximum burst size. Yes,
yes.
it is partly true. If the relaying node, routers or switches have a limited amount of buffer, then definitely it has to be considered as well. But in reality, the buffer space is quite abundant in most of the cases. So we don't care much of the buffer spaces when we consider the admission decision. But you are right, yeah. Buffer size also has to be considered. Yeah, thank you.
Okay, thank you. I think we can we have good consensus on this. Thank you.
Thank you.
Torles. Torles Eckert. Yeah. So just quickly on the buffer space size, right? So that is actually an interesting thing that we may want to revisit in general. So if we look at the lower end of forwarding plane chips in the high speed, there are two classes, right? So the ones with a lot of buffer, which are meant to be used for routers, and the one with a lot less buffer meant for switches. But if you look at, for example, metropolitan networks, right, many of them try to get away with just the low buffer, right? Whether that is still too low for us for what we are trying to achieve or not, I think that's actually an interesting question between these two different type of devices with a different size of buffer. But I think that's kind of mental note for to be investigated.
Yeah, if our devices has very little buffer sizes, and I think that's a one possible scenario, right?
Well,
in that case, we have to consider seriously about the buffer size. But you have to remember that in all the solutions currently being proposed in DETNET services, has very low end-to-end latency bound.
Yeah, exactly. Yeah.
And in order to meet those end-to-end latency bound, the buffer size itself should not be very large.
Right.
Yeah. So these are, I think, trade-off. Yeah.
No, I think for somebody coming from the industry that doesn't want to try to drag through all of our details here, it would just be good to know that whatever we need as buffer size would fit, for example, into these lower buffering equipment, and these type of applicability statements that we can get out of the analysis.
Right, that's a good idea. Maybe in every solution we can specify the required buffer size as a kind of parameter of that solution. That's a very good idea. Thank you.
What I wanted to get to is, I think the thing that might also be useful to add is the older algorithms so to some extent they're here, right? ATS, I would say, is an older algorithm, not well scalable. But for example, would it be fair to say that kind of C-score is what RFC 2212 INSERV is doing, just scalable, and so that we try to have this, even if we haven't considered them because we think they're not scalable, that we have them in for comparison, because then people can already know this is roughly the same service I'm getting.
Right,
now
right. That's a good idea too.
Added, yeah. Thanks.
That's a good idea too. Actually, the Fairking and C-score are in line of integrated services that started from very long time ago. So that's a very good idea. Thank you.
Okay, this Chuan Sheng from ZT. Thank you for your hard work on the detailed category. My concern is that, like the page shown, that it can be the treatment solutions can be categorized based on their performance, and for example, the latency, loss tolerance. I think just like this SLA requirements, but as you proposed in draft, there is existing just the latency band, and it is categorized based on the per hopper dominant factor. So
Right.
it's not just not under tight latency or loose latency. Is there any relationship with the tight or loose latency?
Yes,
under
that's a very good question. Actually, I think, personally, I think many of the solutions we are currently proposing doesn't have explicit expression for end-to-end latency bound.
yeah.
However, we can roughly figure out what are the perhaps behavior characteristic, and based on the characteristic, the perhaps latency bound should be. And yeah, these are the basis of categorizing the solution into three parts. So yes, there is no strict mathematical proof that each solution fit into this category, but I think it is agreeable. One exception to that rule is the C-score or fair king has explicit end-to-end latency bound expression. So it is correct. It is very accurate. But other than that, it is a rough categorization.
Okay, I suggest to do more clarification or the category based on the performance.
Mhm.
Do more add more category based on the latency or jitter or the noise.
Mhm.
And like you show in the slides, I suggest to add
okay.
some clarification on the draft.
Okay, thank you. I remember that you
Yeah.
suggested to include the jitter performance as well.
Yes, yes.
Yeah.
So we can do more
Yeah, I'll
discussion.
try my best
Okay,
to
thank you.
include that aspect as well.
Yeah, thank you.
Thank you.
Hi, Dan Bogdanovic. So going back to the buffer, when it gets down to silicon, you have some of the older silicon where the buffer and the table sizes are pretty much fixed. And then you have some modern silicons where you can play with that and saying, I want more for the table size or I want more for the buffer size. And you have to do a trade-off because you have a finite amount of resources on the die that you
Right.
can use.
That's correct.
So there's always a trade-off that you have to be willing to do, and then you have to decide, will I do a trade-off on the flow side and have less flows, and I will be reprogramming the flows more, or I will be using less buffers and doing the reprogrammings of the flow less.
Right.
So this is the key trade-off when you are designing a system that you have to do, and you have to be aware of how many resources are you using within the system.
Thank you. Thank you for the comment. That's very accurate. Actually, the solutions in other area may have flow state table and so on, but in DETNET solutions usually cannot maintain the flow state. So I suspect that the flow table or any other table type of information, that information amount, it should not be very large. Yeah, but still we have to consider the balance between two aspects, and it has to be specified as well. Thank you.
While Balaj is going to ask his questions, we're going to start a poll leading towards asking about adoption. But I want to do that in parallel with the discussion. So Balaj?
Okay, Balaj Varga. I have a high-level comment. So on Monday, we had some discussion about wireless-friendly functionalities in order to provide the latency bound that we intend to have. So my high-level comment would be that it would be great to involve some aspect of that wireless special cases in order to evaluate these queuing methods also from that perspective.
Okay, thank you very much. Yes, right. Now our working group collaborate the wireless effort and the wired effort all together. But I admit that current solutions are basically concentrated on the wired part only. Yeah, wireless aspect has to be considered in the future and from now on. Thank you.
Okay, we had a little participation in the poll, not heavy, and something like 20% have read. So we have had some people that have read. I'm interested if we're interested in knowing who thinks that this is a good foundation for our work. Not that it's perfect. I actually have some technical comments myself on wanting to change and clarify some of the terms, but that doesn't change the question of, is this a good foundation? Is this a good starting point? Not endpoint, but starting point. I should have started the poll, sorry, while I was stating it. In terms of my own comment, we can work offline. I think the ordering is a little confusing, service ordering, because we use ordering in terms of pre-auth. It'd be better to find a different term just to avoid ordering. I think also some of the other terms are not as tightly defined. For example, tight and loose latency is not, I don't think we have a good tight definition of that. So I think we need to do that. But personally, I think we could do that after adoption.
Okay, thank you. I'll take that in mind.
Yeah, I'll make the comments on the list too. So, but as chair, who's running the poll, I want to just say it looks like we have some pretty good support of the participants saying yes, they think it's a good start. As always, we judge consensus on the list, so expect us to take this to the list. We're a little over, so I'm going to ask that the person who says no, I'd really like to hear why they think no as part of the adoption poll. If you can express to us why you think it's not a good starting point, that would be really appreciated. Thank you. And Jinu, thank you so much for the presentation.
Thank you very much.
Hi, good morning. This is Super Pan from ZTE. I will present the line-based forwarding mechanism. Next slide, please. So from version 7 to 9, the updates as below clarify the process of the latency composition and the bus accumulation context according to the discussion in the main list. And the supplemental figure for each option, especially options with latency composition, is termed as CEDF, and describe two implementation methods for on-time scheduling to absorb latency deviation E, the ED integration or ED decoupling, and the supplemental common topology example, and the last is the taxonomy considerations. Next slide. So this is the motivation. Why do we introduce EDF for large scaling requirements? But I will no longer provide a detailed description again. Next slide. Next slide, please. Thank you. So this the first update. This page illustrates how latency compensation work. For latency compensation, with the help of latency deviation E, we can always get the ideal arrival pattern. That is used by EDF scheduler to rank packets, no matter what is the shape of the real arrival pattern. For a specific flow, the ideal arrival pattern equals to real arrival pattern plus its latency deviation. And the ideal arrival pattern of node H equals to the ideal arrival pattern of interest node plus H multiple D. Next slide. So this is the second update. Generally, there are 4 options that the EDF may take. I will not also go detail for each option. In summary, the one on the left side is the traditional EDF based on traffic regulation, while the one on the right side is the recommended based on the latency composition, which is termed as CEDF. Next slide. So this is the third update. For anthem mode, it may eliminate the burst accumulation, making buffer design more simple. Anthem mode can be further implemented in two methods. The first is ED integration. The packet is scheduled by the scheduler configured with anthem mode based on D plus E. The end-to-end latency is in the range D multiple hops to D multiple hops plus DI. The second method is ED decoupling. The packet is scheduled by the pre-scheduler configured with anthem mode based on E, and then scheduled by the post-scheduler configured with in-time mode based on D. The end-to-end latency is in the range from D multiple hops minus 1 to D multiple hops minus 1 plus DI. Both two methods may provide JIT of delay level value DI. Next slide. So here we give a common topology example used to describe the service scaling degree of DETNET mechanism. Suppose the link speed is 100 Gbps, and the T-spec of each flow is that the packet size is 1000 bits, average bandwidth is 10 Mbps, but the R-spec of each flow is different, which is natural in the actual networks. In this topology, we let each flow face full competitive flows at each hop. Next, please. So this page shows the admitted flows for each delay level. It may support approximately 6,500 DETNET flows in this example. There is no overprovision. The admission check is a node based on buffer size per each delay level duration, and it provides customized performance latency. The performance latency of flow is based on its R-spec, not its T-spec, that is service flow rate. Next slide. According to the criteria defined in taxonomy document, DETNET mechanism is a non-periodic asynchronous class level, work conserving and non-work conserving configurable, in-time and time configurable, delay-based scheduling scheme. And the performance latency dominant factor is delay level itself. For non-periodic, there is no defined periodic qualification unit of scheduling power. For synchronous, all DETNET flows arrive synchronously. Okay, for class level, the flows is grouped by delay levels, and it can be configured in time mode or on-time mode to achieve work conserving or non-work conserving. For the delay-based DETNET flow is scheduled based on its expected delay level, not on its reserved bandwidth. Next slide. So that is the whole of this question. Any questions or comments? Thank you.
Any questions? It's 12 now.
Okay, I will continue to describe the TGAF mechanism. Next, please. From version 4 to 6, we have the following updates. Clarification of some mapping relationship, the BTM, DOM, and FTM, and runtime policing delay jitter elimination, and common topology example, and taxonomy considerations. Next slide. Yeah, for motivations, most of the scheduling mechanisms have a contradiction between latency performance and the service scale. Flow interleaving can significantly improve service scale. TS and TS introduce a flow interleaving method based on GCL rotation cycle, but it needs time synchronization and has scalability issues on GCL calculation, updation, and installation. To meet the large scale requirements, this document enhances TS to introduce time slot resources to layer 3 and related time slot scheduling on DETNET plane. We call it TGRAPH mechanism. Next slide. The key design is to introduce a time period, which is termed as orchestration period. TGRAPH will construct the time slot type of resources for each link. And we decouple the orchestration period from the scheduling period. The latter matches the actual hardware capacity of the device, requiring only a few round robin queues or a single pipe queue. The path calculation is based on time slot resource reservation on each link, and obtain a flexible mapping relationship between the incoming time slot and outgoing time slot on each node. It should be noted that the orchestration period is not only used on the management and control plane, but also on data plane. Next, please. So this is the BTM, BOM, and the FDM. For a given topology, each node and each link enable TGRAPH and rotate its time slot independently, and there are fixed BTM or BOM for a unidirectional link between any adjacent nodes. BTM is the local outgoing time slot mapping to the remote ongoing time slot, and the BOM is the orchestration period phase difference between the local orchestration period to remote orchestration period. BTM or BOM may be detected based on the topology related fixed BTM or BOM. A DETNET flow may allocate the time slot resources on each node and obtain flexible FTM that meet its latency requirement. The flexible FTM can achieve flow interleaving. There is an argument that the flow interleaving only on the network entry. I think it is hard to avoid congestion on the transit nodes. Next slide. So this is the runtime pollution delay jitter elimination. After the pollution at the network entries node, there may be a runtime deviation E between the ideal arrival time and the real arrival time at the scheduler. The runtime deviation E is treated as a part of pollution delay because different packets may have different pollution delay, so that the jitter occurs. The pollution delay may be eliminated by the calculated endpoint damping delay and the egress node. The endpoint damping delay equals to the preset budget minus head and pollution delay. Next, please. Here we also describe the service scaling degree of TGRAPH mechanism based on the same topology example. Next, please. So this page shows the admitted flows for each time slot. We suppose that all flows arrive concurrently, and the different reserved outgoing time slot may produce different residence load delay. It may support 10,000 DETNET flows in this example. Yes, there is also no overpollution. That is, admission check is not to let a burst of flow consume all time slots, and it provides customized per flow per hop latency. The per hop latency of flow is based on its R spec, and achieved by time slot reservation, not by its T-spec. Next, please. So this is the taxonomic considerations. Okay, it's also according to the criteria defined in taxonomic document. Trigger of mechanism is a periodic, frequency synchronous, class level, working conserver, non-working conserver configurable, in-time or on-time mode configurable, and time-based scheduling scheme. The probability dominant factor is time slot offset by reservation. For periodic, firstly, there is a time period P containing multiple time slots, and secondly, a flow is assigned repeatedly to a particular set of time slots in the period. For frequency synchronous, crystal frequency aligned to ensure that all nodes have the same time lapse rate. For class level, DETNET flows is grouped by time slot ID. For working conserver and non-working conserver configurable, the scheduler configured with in-time mode can achieve working conserver, while configured with on-time mode is non-working conserver. For in-time or on-time configurable, a scheduler may be configured with in-time mode or on-time mode. For time-based, DETNET flow is scheduled based on its outgoing time slot rather than its reserved bandwidths. That can fit well the case of low bandwidth consumption but urgent flows. Next, please. Okay, that is the wall of this version. Thank you. We welcome to any questions or comments.
Any questions? I'm 13 now.
Thank you for that. I think next up is Shanu.
Thank you. The C-score draft, version 2. In this revision, not much has been revised. The category of the C-score, according to the taxonomy draft, is addressed, and the strengths of the C-score has been described. That's it. However, in this presentation, I will add some explanation about the C-score to help you better understand with an example that starts from ECQF. So I don't have much time. So this is the one you just saw in the taxonomy draft presentation. C-score fits into rate-based, flow level, L over R category, as well as the work-conserving scheme. So this one, you have also seen it. I'll give you a brief amount of time to look over it again. And from now on, I will describe the strengths of the C-score. First, it has a very simple admission control scheme. The admission and reservation process depends only on the service rate to the flows, while others require to consider the burst sizes of all the flows. So you can accommodate the large number of flows that joins and leave dynamically. The second strength is a flow isolation capability. It can minimize the effect of other flows burst. And one other strength I have not mentioned in the draft is that it has the explicit expression for the latency bound that you are seeing now in the upper part of the slide. You can take a look at the symbols on the right below side. you can have some time to look at the expression, or what the meaning of the expression. The important sum term here is L over R at the very end of the expression. This is the per hop dominant factor for the end-to-end latency bound, this L over R. So the whole category belongs here. So it provides a near perfect flow isolation. Why it called near? Because the Lmax is what? Maximum packet length of maximum packet length at node H over all the flows. So it depends on other flow. But other than that, every parameter here belongs to the flow itself. So the end-to-end latency bound itself is very flow's own parameter dependent. And according to that fact, the admission process is very simple, and so on. So if end-to-end latency bound is guaranteed to a flow upon its admission, it alters minimally as other flows join or leave. That is the strength of the C-score. The third strength is from its statistical multiplexing gain, as I have just described in the previous slide. It has small average latency, it has small observed maximum latency, thus more room to best effort traffic. Altogether, it can be called a statistical multiplexing gain. About this box plot, there are 4 solutions presenting. The left 2 are called jitter virtual clock and core jitter virtual clock. These 2 are proposed by Ian Stoica a long time ago. It is a very well-known scheme, but it is non-work conserving stateless working. These 4, including the virtual clock and C-score, they all have the same maximum end-to-end latency bound. In this parameter, it is 0.32 millisecond. So you can see that all 4 schemes meet this theoretical maximum bound. Much lower than the theoretical latency bound. More than that, the non-conserving working schemes, the averages are very high. These are the distribution of end-to-end latency bound. So the simulation has been repeated quite many times, and the distribution of end-to-end latency is plotted here. The average end-to-end latency for the non-work conserving schemes are very high, while the work conserving working schemes has very low average end-to-end latency, and the maximum observed latency as well. So it certainly shows the strength of the maximum multiplexing gain. And this is why internet has succeeded. This is the major revision in the draft. From now on, I will try to make you understand better why C-score is very useful. Let's start with the example of enhanced CQF, which is being processed in IEEE, and I was told that this scheme is quite stable now. This is called enhanced CQF. Similar to CQF, the time is divided into slots, but different slot lengths are allocated to different classes, as you can see here. But the basic CQF end-to-end latency bound still applies. That is similar to or close to the hop count times the slot time. This is the end-to-end latency bound of basic CQF. So you can see here, the higher the class, the slot length is small. So end-to-end latency bound is differentiated. That's the whole idea of the eCQF. However, how the slot length is determined? That's the main problem. How you define the slot length? Roughly speaking, it depends on the maximum burst size, the sum of maximum burst sizes of the flows in that class. And if the maximum burst size is suppressed equal to the packet size, then the maximum packet sum of the maximum packet sizes determines the slot length. However, that determination has to be done in the most congested link in the network. So it has to be very large. Moreover, if a single class's slot length is determined that way, it also affects to other classes' slot length. So the slot length is very unflexible, I would say. It is very rigid. So when more flows are admitted later, then all the slot length has to be increased, or the initial slot length has to be large enough to accommodate the future flow admissions. So I call it is flow interdependency. The flows are interdependent with each other. How can you solve it? For example, we can come up with a flow level ECQF. That is, not based on the class, but based on the flow itself, the slot lengths are assigned. The slot lengths can be assigned, for example, depending on their maximum packet length and the service rate of the flow. If that happens, a single box area equals to the maximum packet length. And how do you decide the service order? You can decide the earliest slot end time first. So whenever the slot ends, the earlier the slot ends, that flow will be served. You can serve like that, then you can have flow level ECQF. By doing that, the end to latency bound is still the same. And even when more flows are admitted, there's no change in the slot time, thus unaltered latency bound. You can achieve flow isolation by doing the flow level ECQF. However, there's a still problem that bandwidth can be wasted because of the variable packet size, because the slot length has been assigned based on the maximum packet length. So we can improve it even further by having variable sized slot scheduler, flow level ECQF. So now the slot length is not fixed, but variable according to the packet it has to accommodate. No wasted bandwidth, a similar end latency bound. So this is the best you can do with ECQF type of the schedulers.
We're going to have to close soon. Could you speed up a little?
Yeah, this is the last slide. But we already have the solution. The solution's name is called C-score. It is flow level, variable sized slot scheduler, but it is even work conserving. That means even before the slot end time, the packet can be served. And its theoretical maximum end latency is similar, slightly different, but because of the non-preemption characteristic of the Cisco. Thank you.
Time for a question? Any questions? Shofu?
Hello, this is Sefu Pan from ZTE. Yeah, thank you, Jinu, for the presentation. I think maybe we can supplement the common topology-based example to show the benefit of Cisco. I have two concerns. The first is the probable latency, the level of the probable latency. For example, it may be 10 microseconds or 100 microseconds. And the second concern is that can Cisco provide multiple probable latency similar to multiple priority?
Sorry, Shafu, could you repeat the question again? Can you make it a little shorter?
Okay, I'm sorry, terrible English. The first concern is that can Cisco provide the common topology example to show the benefit of to show it benefits? And the second question is, I want to know if Cisco can provide multiple class level. Yeah,
Oh, yeah. Of course. That's strange. Okay, I can.
We might have to take it to the list because
Okay, sorry.
we should switch.
In the short term, in a short answer, I can say that the maximum end-to-end latency bound of a flow can be adjusted.
Yeah.
With any value, adjusted to any value by adjusting the service rate to the flow. So I think
Yes,
that answers your question. And if you have more question, please.
Let's take the discussion to the list. We're running
Okay, thank
into Yan Cho's time.
Thank you.
Hello everyone, my name is Yanchul Liu from ETII. It's honor to present it on-time forwarding with Pi4Q method. There are 5 contents to present it today. DETNET is provide a bounded end-to-end latency. If maximum latency variance are guaranteed, it is called on-time forwarding. On-time forwarding is a critical feature in the industry, so we propose a new method that allow the more accurate on-time forwarding and more flexible flow setting. Our terminal model separated end-to-end latency into the 2 components, variable delay and fixed delay. Variable delay has its upper and low bound. For example, queuing delay, processing delay, and output delay. In order to provide on-time forwarding, variable delay upper bound must be smaller than maximum end-to-end requirement minus fixed delay, and variable delay low bound must be bigger than minimum latency requirement minus fixed delay. So we assume the variable delay upper and low bound is divided, and controller assign the node delay upper and low bound. And then when a packet arrives at the time t, node calculate the minimum departure time and maximum departure time. Minimum departure time is calculated by arrival time t plus node delay low bound and minus their mean, which is the minimum time it takes from the time a packet leave the queue until the leave the node. And then maximum departure time is calculated by arrival time t plus node delay upper bound minus their max. Their max, which is maximum output delay, expected maximum output delay. And then packet is placed in the Pi4Q in the ascending order of the nominal departure time, which is the midpoint between the minimum and maximum departure time. And then when a minimum departure time of the head of a queue has reached, then the packet is dequeued, and then finally when a packet leaves the node, subtracting the residence time from the received remaining end-to-end latency upper and low bound. This is the example of the mechanism data plane operation. Assume there is 3 flow. First packet P1 arrive at the node. P1 placed at the head of a queue, but cannot leave the queue calculate cannot leave the queue before the calculated minimum departure time 1.2 millisecond. And second packet P2 arrive at 0.4 millisecond and calculated nominal departure time is 1.57 millisecond. Since the nominal departure time of the P2 is smaller than P1, so P2 is placed at the head of a queue. Finally, P3 arrival at 0.6 millisecond, and since the calculated nominal departure time is smaller than P2, so P3 is placed at the head of a queue again, and then at the 0.9 millisecond, P3 leave the queue as its minimum departure time has reached. And following the P3, the P2 immediately leave the queue as its minimum departure time has passed. Finally, P3 is DQ at the 1.2 millisecond is minimum departure. P1 minimum departure time.
Is it not working? Try next. Try again.
Next, please. Oops.
Go ahead. We'll go back. Yeah.
Control plane operation is firstly collect the resource and delay related information, and if the new flow are requested, select path, and that path is can satisfy the requirement, and following two condition, and calculate the node delay upper and low bound to all node for on path, and then two node delay upper and low bound have met the following two conditions. Our method, the last node is the node that can take final action to ensure the variable delay low and upper bound for on time. So node delay upper and low bound of the last node must be determined first. Last node delay upper bound is recommended to set the as large as possible to possible the buffer resource of the last node allow the flow, and last node delay low bound is minimum time to transmit any preceding packet of the earth flow of the last node. And previous node delay upper bound is remaining value after subtracting the node delay low bound of the last node from the variable delay upper bound. And previous node delay low bound is assigned as remaining value after subtracting the node delay upper bound of last node from the variable delay low bound. Proposed solution has the following characteristic for the requirement described in the DETNET scaling requirement. The solution does not require the time synchronization, but need to frequency synchronization. The solution large single hop propagation and delay is supported, and high link speed is supported, and does not require to maintain the flow state, and robust against node and link phase and topology change. And flow fluctuation inherently does not occur. And there are no scale issue regarding to the number of the hops. Thank you. Any question, comment?
We're good. Torles.
Yeah, thank you very much. Couple of points. So I guess you're assuming with PIFO that you can explicitly say what the intended departure time is?
Departure time.
Yeah, so in terms of the PIFO has a basically control parameter. So you didn't explain further how you're planning to use the PIFO. So I assume you're calculating the intended departure time, the nominal departure time, sorry.
Yeah.
And you're giving that as the control parameter to the PIFO?
Yeah. First of all, when a packet arrives and we calculate the minimum and departure time according to the node delay upper and lower bound. And then according to the nominal departure time, DQ in queuing in PIFO queue. And this is arranged ordering. This time is using ordering time, and then packet is departure at the minimum departure time.
Right. So, well, first of all, these high-speed PIFO implementations, they're just in the process of coming. There is a hopefully good paper from CMU this year. Forgot the conference that it's at. That's showing a scalable algorithm. There was another one last year. The implementations from researchers that were done before weren't really well scalable. There is still the point missing that the PIFO control parameter can be an actual timestamp, right? So that is still for them. You know, I've been trying to push them to also include that, but they want to get their current work first published. So currently, the control parameter is a priority, right? So you can't continuously increment it. So there is one more level of FPGA complexity to get working before PIFOs can really start to move into the industry. As far as this mechanism is concerned, this is very similar to what we did a few years back as a research paper, LBF, which is referenced in our GLBF document. And so the reason why we gave up on that is because the flexibility of this mechanism is so large that we couldn't figure out, and I don't think you have done that either, to describe an actual calculus, meaning the math that I can take to figure out there are flows coming that want to get admitted. I do a calculation and I need to know what latency can I guarantee to them and what total bandwidth can I guarantee. And obviously the characteristics of the flows that you have, like burst size and rate, how you characterize the flows, will have a big impact on, you know, what you need to calculate as the worst per hop latency. Implicitly, these delays that you give them per hop is some form of shaping that, you know, has an impact on the burst size hop by hop. So there is a humongous amount of flexibility, and if you can make progress in actually getting towards a calculus, that would be great, because I pretty much gave up, which is why we kind of converted the idea to the, okay, what can we do simple with the PIFO? And that was then the simple damper with using the ATS, UBS calculus. And that is the GLBF draft that we already presented, right? So, and the big benefit of that is that, so it's a very simple calculus. And with the damper, we can even implement it in FIFO. So it can even be earlier implemented. So this whole flexible stuff, yeah, the calculus is the trick. Maybe the PIFOs will come earlier before someone has a working calculus for this.
Thank you.
Penglu?
Pulling from China, just for the maybe slide 9, capability analysis. Yes, for point 3, I just want to remind that the higher link speed will influence the time control and the buffer set. I didn't see the explanation in this section gave a really reasonable analysis. So I hope that both in your draft, you should enhance this section to really get capture the points of the behind the requirement.
Thank you.
Thank you.
Xiaofu?
Hi, this is Pen from GT. I have two questions. The first one is I saw the text in the document that the node delay with low bound and the node delay with up bound should be installed on each node for the flow. Does it current in the packet? I'm sorry. So I will repeat my question again. For the node delay of low bounded and the node delay of up bounded, does the parameters for the flow is carried in the packet?
No, that will be carried in packet.
Okay,
Then
thank you.
we assume the configure that the node, but if the previous node, all of the node delay up and low bound are same, then two parameter can be carried by packet.
Okay, thank you. Okay, the second question is that yes, the document described the node delay of up-bounded is related with the packet that have already existing in the queue. I wanted to know if there are any mathematical equation to compute the packet amount.
Did you say
Okay.
we need
Sorry.
to add a mathematical
Yes. Yes,
equation?
to calculate the packet amount that affect the node delay of up bounded.
Okay, we try to update the mathematical
Okay,
part.
thank you.
Thank you.
Okay.
So we had made a miscalculation in the schedule and we thought we had less time than we do. So since we have more time, we'd like to invite Janu to come back and for Xiaofu to come back into queue and to finish asking his question, and maybe we could discuss it a little bit. We have definitely extra time for discussion. So
Okay.
Janu, still in the room, hopefully.
Do you want the presentation back up?
It's sure. It was just the previous presentation. And Xiaofu, if you want to repeat your question. Thank you.
Okay, thank you, Chair, for giving me more time to describe. Okay, Jinu, maybe I can repeat my two questions. And the first one is, I think it is benefit for us to provide a common topology-based example to show the service scaling provided by each solution based on common topology. That is my first question.
Yeah.
What do you think?
A common topology. That was discussed in the inter-meeting before. Yeah. And I think the conclusion there was that because some of the DETNET services are based on the small scale network, and some are based on the large scale networks, they all fit into different solutions. So if the solutions are meant to be used in different topology, how can we come up with a common topology network? to evaluate all the solutions. That was our conclusion, I think.
My opinion is that maybe we don't emphasize the common topology. I think maybe it is useful for each solution to provide topology that it thinks is suitable for this solution to provide some quantification of the output of the solution.
Yeah, any solution can come up with its own topology to provide the strengths or show the suitability. But in that case, a solution have each different topology, then we cannot make a common sense of common topology, right?
I agree with you that I emphasize that it may be not a common topology, but maybe individual topology for each solution. I think it is maybe to give more text in each solution to show the quantification of the output of each solution.
Let's discuss that in somewhere else. I think we cannot make an agreement on that issue.
So perhaps we can introduce that concept of a reference topology into the taxonomy document to illustrate what's meant by scale. Because if this is tied to scale and we have these terms which are a little amorphous in the taxonomy, maybe by giving references, it'll help qualify those terms and the evaluation of different solutions.
Yeah, I agree.
Okay. Okay, I'll think more about it. A reference topology. Okay. Yep. Thank you.
We have another question.
Yes. I'm sorry. Can I continue?
Yes, Xiaofu, continue. You had a two-part question, so you only asked the first part.
Yes, the second question, yes, it is also about the multiple level. Yes, I understand the Cisco can provide the multiple level. For example, the probable latency is just the packet size divided by the service rate. Yes. So it seems that the probable latency is just the packet interval. That means for a flow, the packet 1 is sent, and after time duration, the second packet is sent. So the probable latency for this flow is just the packet interval. Yes, for different flows, they have different packet intervals. So I think this is the multiple levels provided by Cisco. I'm not sure if I understand correctly.
I'm not sure if I understood your question correctly, but the equation here, I mean, the expression shown here is end-to-end latency bound.
Yeah, but the end-to-end latency bound is computed by the probable latency multiplied by hop counts.
No,
yes,
not at all. No, that's not the case. Some of the solutions may come up with the per hop latency bound and then multiply by hop count, right? That's the case of CQF. But in the work conserving rate-based solutions has pay burst only once property. The pay burst only once property can be seen in this expression as well. The large B is the maximum burst of that flow, and it is not multiplied by the hop count, right? So that's why it is called pay burst only once. So the per hop latency bound, if you insist, is it includes the B. It includes the B. Per hop latency bound includes B. But over the hops, the burst is paid only once. And the end-to-end latency bound is also a function of B1s. So it is not the sum of the per-hop latency bound. I think I have explained you so many times about this
Yes,
property.
I'm sorry, I still misunderstand it. I think we can discuss it more in the mailings because this is well trivial.
Yeah, I can recommend you a very good paper.
Okay, thank you.
Thank you.
Thank you.
Abdul Salam.
Yes, I sort of agree with Shaful for there should be a reference, maybe not, I will not say topology, but as he said, there should be some kind of reference. And to answer to the chair, I was the one who maybe said no. My reason is that the taxonomy, this taxonomy is very important, but I still don't see as a taxonomy. I would like to see it how it's reference, as Chef will say too, maybe the use case, mostly the, let's say the application for the DETNET, or let's say we say, let's say use cases, which is current. As you said, there was one slide you mentioned, number 9. It was maybe I think it's the best taxonomy. I can feel it. It's close to the use case. Is slide number 9. That's maybe if we can focus on slide number 9, or you make it more in details referenced. I think that will be no, not this slide.
Okay. Yeah, okay, I understand.
Anyway,
I understand your.
it was having the service rate and the flow, and there was something three categories.
Okay.
And you had one of the slide has some categories, but they are in the same level. Sometimes categories you can, and you went very deep in making groups of these. It's fine, but at least in the end, I would like to feel that, as Shaful said, there's some kind of referencing to the current implementation, which is the DETNET or the application or the use case, you can say. So that way we can use this document as a background. Thank you.
Okay, thank you very much for the comment. I will briefly answer your question. The reference topology will be needed, and we will come up with that topologies. But I cannot say that can be only one, maybe one or two, maybe including wireless environment as well. So I, Torle, Xiaofu, and Suesong will discuss about that and come up with one or two or multiple reference topologies. And the use case, actually the focus of the taxonomy draft is not the use case. It's a very complex job to list all the use cases. And we have use case draft in our working group as well, one or two. So we will reference those use cases, not inventing a new use cases. Thank you. Torles?
Torles Eckert, yeah, on the reference topology. So I think you mentioned it many DETNETs in before, that the rings were something that was shown also to be the most difficult part for the deterministic latency algorithms, which I think is also why, for example, if I think I remember correctly, the validation that was done by the professor that was doing the UBS algorithm, that they also used a ring. And for me, it may not be, common everywhere, but rings are a very cheap way to get through a city. So there are certainly, rings for metro areas. So a very simple thing is to come up for kind of algorithm for scaling a large ring, right? Obviously for just quick validation or so, it's a simple, smaller ring like in these research papers, and then each of the nodes can also be a hub for more routers, right? So
Right.
that seems like a very good thing that can be scaled up and down, and has introduced the big problem that in a ring delay can increase, if I remember
Right, exactly.
you correctly, and it's actually also real world. So I think that that would be a good start.
Yeah, ring looks very simple, but it is very tricky, as Rolla said. It introduced the cycle in the topology, and the burst accumulation can feed forward, and it can explode. So it is very good reference architecture. Yeah, ring should be definitely will be considered. Thank you.
Still, Lou?
Yeah, so I think this is a chair comment. I agree with the speaker that this document is not about use cases. I'm sorry, the taxonomy document is not about use cases. That's the use case document. So I agree that it doesn't belong there. In terms of having some reference topologies and perhaps multiple, that sounds like a great idea. From a process standpoint, you listed the authors as the ones inserting it, as coming up with those topologies. As an individual document, you're correct. That belongs with the authors. But as soon as we adopt, it belongs to the working group and anyone can suggest it. So the question is, do you want to get your topologies in and then go for adoption poll? Or do you want to adopt and then have the working group work with you on those topologies? And in the end, the working group's going to work on them because it's going to be a working group document.
Yeah, I'm not very familiar with the working group process, but I definitely would be accepted as a working group document first, and then proceed as a working group document.
Okay, that's great. I think we would like that as well. I haven't talked to Janos about it, but I suspect he'll be on agreement on that. But that does mean that the working group works on the topologies, and anyone can provide input, not just the authors.
Okay.
Thank you very much.
Thank you. More questions?
Okay. Yeah. Abdussalam? We can't hear you.
I think he's no longer in the meeting, so maybe move to Antoine.
Okay, I'll Antoine.
I wanted to express my agreement with the document being adopted before the topology work being included in the topology together with the topology document. Topology document is already a large amount of work, and once again, thank you for putting this work together. I think that topologies and use case inputs should come from operators and people deploying networks. From network vendors and academics, sometimes figuring an abstract topology from a use case is a very funny exercise, but doesn't come close to real life deployment. And if we can have experience from network operators that can show example topologies where they want to deploy large-scale DETNETs, I think it would benefit the evaluation of the different solutions that we study in large-scale DETNETs to fit with real-life deployments.
Yes, thank you. So that's why we need many inputs from all of our working group colleagues. Please provide inputs. Thank you.
Yeah, and Antoine, if you have any actual topologies to offer, that would be great, right? So I've repeatedly struggled, especially when helping researchers to know what topologies can publicly be given, right? Because the ones I know of are very often not public, right? So which is why what we as vendors typically try to do is then to do simplifications down to reference, like what I said, ring with each ring node being a hub or so, that's sufficiently anonymous that it doesn't point to any individual deployment I know, which, so yeah, but anything that you do know that is realistic, that would help greatly.
Yeah, just to clarify, I have the same struggle, and this is clearly a struggle every time you do network measurement, evaluation of network topologies. Having real-life deployment is a real struggle, and we would really value, I would really value input from operators on that.
So, Anton, yes, that would be ideal if operators contribute topology, but we are contribution driven, so we have to live with what is contributed. Thanks. Abdullah Sam, please make your question.
Yes, just my comment was when I meant by it, the use cases. It says a reference application or the use cases, which is let's say documented already, can be referenced to help the taxonomy. So, or even the topologies can be. It's usually the topologies for use case. So if you want to reference a topology, or even you reference the use case, it's similar. It's not different. I don't see much difference between them. But anyway, you can at least we have some kind of reference for the taxonomy. Thanks.
Yes. Yeah. Of course, the topology and use cases are related. That's why we have already referenced some of the use cases draft currently being processed in the working group. Thank you.
I lost the slide decks. Bella's, sorry, Janos, can you give me control again? Yeah.
Sorry, just like somehow something went wrong with my WebEx, so I can't. Sorry, with my just wanted one quick comment on that stuff. So I think we may have, the same type of topology also issues also for other functionalities in DETNET, right? So, for example, what I've seen much in the past is that the path steering that we want to have the path on which we guarantee the bandwidth, that of course has a lot of different options that we haven't really talked about that much, except for potentially for every flow to stick down the path. And but then there are other options like these IGP topology extensions and so on, and how good or how bad they work does work a lot on topology. And but the complexities for that path selection, that's actually a different issue than the complexity for our admission control for the bounded latency, right? So we'll have to be somewhat aware that whatever we're doing for the bounded latency work here may not necessarily expose all the complexities that we get into when we're talking about, fixing down the path
Right.
for the guarantee, because
I
that
think,
complexity we should leave out if possible, because otherwise we're taking on too much.
Right. I believe that if the reference topology is given in the taxonomy draft, that will clearly influence other documents in the DETNET working group as well. For example, the requirements document, of course, the older solutions document. So we have to, I think, very careful, and we would like to get as much input as possible. Thank you.
Okay, next presentation coming up. Thank you.
Hello, everyone. This is Chuan Shong from ZT. My topic is flow aggregation for enhanced DETNET. Thank you. So this is the agenda for flow aggregation in enhanced DETNET. We may first discuss the gaps and the requirements for the flow aggregation and provide a consideration for flow aggregation in scaling network. First, the gaps and the requirement for the flow aggregation that is we need to provide aggregating to aggregate the DETNET flows to resolve the scalability issues at the transit loads. For first, as per RFC 9522, the DETNET may have their concern from their scalability issues and even their flow aggregation at the aggregator level still has the scalability problem. For example, it will have to maintain the aggregate level states by the transit loads, and it will be challenging for the operation signaling control. And as we discussed just now for the category, the class level may be could be provided to simplify and to dynamically to for the traffic fluctuation, and it can provide the aggregation by the same level of the service requirements. So first requirement for the flow aggregation in enhanced DETNET, we considered it can maybe considered for flow aggregation on the class level. Sorry. The first problem to resolve the scalability issues when we aggregate the flows by the class level can further to resolve the scalability, and at the transit loads, it can provide the transmission to at the for the limited aggregate numbers to reduce the states of the flow, the per flow states maintenance. And the second gaps and the requirement is that we sorry. As the requirements in draft described, the different levels of the applications may differ in the SLA requirements. For example, just mentioned the loose latency, tight latency, or the stricter jitter, stricter latency, and so on. This may be categorized by based on the performance, and we just discussed that the treatment solutions in data plane also can be categorized based on the performance, and so for the requirements based on the flow aggregation, we lead to provide the per hop behavior. For example, the different treatment solutions. And so we maybe consider to provide the flow aggregation by aggregating the individual flows into the class level to select treatment based on the performance to provide the fine-grained provisioning. And the third is that we may to aggregate DETNET flows across different DETNET domains. For the requirements, the different network implementation may be intended for different domains. For example, the domains has no cooperation between the domains, and so the interworking should be provided for the flow aggregation. For example, the mapping between the different domains for the queues requirements. So for after discussing the gaps and the requirements for flow aggregation in enhanced DETNET, we may provide considerations about, for example, aggregating DETNET flows on aggregated level, class level. So, for example, we may consider the flow classification and the flow identification for the for the flow classification. We may provide the aggregation for the treatment based on the data flow specific cues characteristics on the aggregated level, class level. And we may consider the predefined classes for the different levels over the applications. And therefore, flow identifications, we once discussed in the requirements draft that we may provide the explicit identifier for the, for example, the IPv6 encapsulation. So if we do the aggregating on the aggregated class level, maybe we consider the explicit class identification and maybe encapsulated for using the existing field or a new field. This is for later consideration. So this is the first initial version for the flow aggregation. We just proposed the gaps and the requirements for in enhanced DETNET. So maybe later we will discuss detailed for the requirements. For example, in scenarios, the 5GS, and then to discuss detailed for the later extensions for DETNET. So comments and suggestions are welcome. Thank you.
Time for a couple questions. Kae-san.
Hi, Chen. This is Xue Song from Huawei Technologies. Several comments for this contribution. The first one is that could you maybe turn a previous slides before, maybe the first requirement. Yes, I noticed that the requirement, especially the scalability requirement, is raised from RFC 9522, which is the traffic engineering scalability kind of issues. Yeah, but from the beginning of DETNET, in DETNET architecture framework or the RFC that have already been published, the flow aggregation has already been considered, I think, from the beginning. I'm not sure whether to select or to get the requirements from the traffic engineering aspect can be used in DETNET directly. Yeah, that is the first question or comment. The second one is that you have mentioned that a lot of different queuing mechanisms may request a different degree of flow aggregation. I agree about this point. So I think maybe the the different kinds of queuing mechanisms can define their flow aggregation independently. So I'm wondering whether it is necessary for the working group to have a document independently to discuss the flow aggregation.
Okay, I understand your concern. The first comment that the RFC 9522 has been released just now, and in the existing version is that for the flat architecture, it has defined the flow aggregation, yes, but it just defined the flow aggregation on aggregate level, not on the class level. So aggregate level is not, it cannot resolve the scalability problem. It just improve the scalability problem. So it is specified clearly in the RFC 9522. It is DETNET has the scalability concern, still have the scalability concern, and it is still be challenging for the, for example, the state control or the state maintaining. So I think we in enhance the latter, we need to enhance the flow aggregation to resolve the scalability issues. So this is.
Yeah, I understand this point because the requirement document of enhanced DETNET have already raised this point, right? And I just, what I'm trying to say is that in DETNET framework, there is flow aggregation already. And from the whole process of the DETNET, the flow aggregation is considered. For example, in Young model, there will be a layer of flow aggregation to allow different type of flow aggregation. Actually, also class-based is allowed. So, and also, yeah, I think the traffic engineering scalability doesn't fit in DETNET scenario directly. That is the point.
Yeah, I agree, but I think that the existing flow aggregation is not very clearly clarified in DETNET working group. So, well, what we
so if you raise the requirement, just point out what is not clearly defined DETNET working group, not raised another traffic engineering document to raise the requirement. I think that is the point.
Yeah. Okay. I think we. I think for the extensions may be related to the traffic engineering, but first that we may propose the further clarification for the flow aggregation. So there may be some relationship between the DETNET and the traffic engineering. That may be the further proposal.
Okay, here's maybe we have some, we can have some conclusion yet. But here's some suggestions. First, just to analyze the existing DETNET documents, especially about the free flow aggregation part. Maybe you can list them from the DETNET architecture to DETNET Young model and to other DETNET, especially the enhanced DETNET requirements document, because the requirements have already listed there about the scalability. And yeah, maybe we haven't get to the second point yet.
Okay.
Do you want to give some response to that?
I think it would be good to take the points to the list because we're actually over and there's one more person in the queue. But I think the point also that you made, Shasang, about looking at the existing documents and seeing where the gap is in aggregation, take a look in particular at the Yang document and the aggregation section there and see and look at and see if there's anything missing. Because I think what you're asking for is already covered, but perhaps I'm wrong. But so please take a look there. And Shasang, if you could take your second point to the list, that'd be great. Alper, you came in before the end of the session, so if you can make it quick, that you're fine. If not, please take it to the list. All right, well, he dropped off. I really, we want to thank everyone. This is for both myself and Janos. We thank everyone for participating in a great session, a great 2 sessions, and a really wonderful IETF. We thank all the contributors for the documents and the discussion, and notably also our in-room delegates who have really helped us out here. So thank you all, and we will see you in person at the next meeting. Thank you.
Thank you. So this has, I see this has 2.
Lou, can you suggest a next meeting, which next meeting that I can attend?
Excuse me? Our next meeting is going to be in Vancouver at the next IETF.
No, not next meeting IETF, the next session.
I don't have this schedule in front of me, I'm sorry. But I would say, open up the